Okay, so welcome back, and now we're going to introduce another theorem called the intermediate value theorem. Okay, so this would be theorem 3, I believe. Okay, so the intermediate value theorem is a very important theorem that's used later on, and it's easy to understand, and I'm going to go through it and then we're going to do some examples. So what does the intermediate value theorem tell us? It says that let f be a continuous function over a closed bounded interval AB. So we've got a closed interval, and the key is that we're dealing with a continuous function over this closed bounded interval. Now, it says if z is any real number that's between f of a and f of b, so we're looking at y values along the the vertical axis, right? So if there's a z, any real number z between f of a and f of b, then there must exist some real number c in the interval ab such that f of c equals z. Now the key to this theorem, this intermediate value theorem, is the fact that we're assuming that f is continuous on the closed interval. Which means, again, remember our intuitive understanding of continuity, of being continuous. You trace without lifting your pencil off the paper. If that's the case, in my diagram here, if I know that the function is continuous over the interval AB that I have depicted here, that means I'm not going to lift my pencil off the paper throughout the whole interval. Okay? Now, if that's true, then guess what? If there's some z between f of a and f of b, then there has to be some c in the interval here such that f of c equals z. It's just based on the fact that we're dealing with continuous functions over a closed interval. Okay? So, and that is the intermediate value theorem. Okay? Okay. Have a great day. We will do some examples.